All right, guys. Stat 1800. Let me get a pen someplace. Okay. Um, what's going to happen in this video? If you look under on the main page of Blackboard, there's a folder called Handouts, and there's a handout One Sample HT Examples. If you open it up, what I've got is I have about 10 examples I want to go through. I'm going to split this video into two videos. So the first video we're going to get through 1 through 5, and then the second video I'll put up will be 6 through 10. Uh, I guess Captain Obvious, if we're going to split it in. Okay, anyway, whatever. You'll see over on the left I have StatCrunch up. So I'm going to use StatCrunch, okay? So first of all, I just want to step back and practice a little bit on finding critical values for following hypothesis testing scenarios. And I think of everything that we did on the PowerPoint. I think everything was really laid out pretty well. That's the reason I used the PowerPoints. But I think finding the critical values, it wasn't explained at all. So I want to go through 4 examples. So first of all, the first question says we're testing H sub O mu equal 100 versus the alternative mu not equal 100. So right off the bat, I know that I have a two-tailed test because of the not equal to. So I'm going to have 2 tails of rejection. The population standard deviation is known, so that tells me that I'm doing a z-test for mu. And I'm using a 0.05 level of significance. So guys, what that tells me is I'm going to have my distribution of sample means, and I'm going to have 2 tails of rejection, one down here and one up here. I'm going to put half of my rejection region in this tail, the other half here. So 0.05 divided by 2 is 0.025 is going to go there, and 0.025 is going to go there. That's why you see a lot of the Z alpha divided by 2 notation in textbooks. It's wanting you to take your alpha, which in this case it's 0.05 divided by 2, and put half of it in each rejection region. Now, we have a z-test, so we have a z-distribution, so we have mean 0, standard deviation 1. You probably already know what the critical values are, negative 1.96 and positive 1.96, because I want to demonstrate that just in case you may have forgotten some stuff. So if I go over here and go to Stat, go to Calculator, go to Normal, then I want to find this area that has left 0.025. So I'm going to go standard, mean 0, standard deviation 1. I want to find the area that has less 0.025. Hit compute, and you'll see I get negative 1.96. This critical value in a two-tailed test always has to be the positive, or vice versa. If I find this one, it has to be the negative over here. So I know that this is positive 1.96. All right, so that's the way the critical value would be found for that problem. All right, part B. Testing the null hypothesis mu greater than or equal to 100 versus the alternative mu less than 100. So guys, I know here I'm doing a one-tailed test. Let's read a little bit more. The population standard deviation is unknown. So I know I'm doing a t-test because sigma is unknown. My sample size is 32. I have a level of significance of 0.05. So guys, I'm only going to have one area of rejection, and it's always going to correspond to pointing toward the tail of the inequality in the alternative hypothesis. So I'm less than. So I'm going to have my rejection region down here, and I want all of my alpha, my level of significance, to be here. So what I have to do is I have to find the critical value from the t-distribution with degrees of freedom 31. Well, turns out that I got a calculator for it. Stat, calculator, t, I want standard. Degrees of freedom are 31. I want the area to the left to be 0.05. So my t-value is negative 1.696. So guys, if my test statistic falls anywhere bigger than negative 1.696, I fail to reject. If it falls anything to the left or less than negative 1.696, then I fail to reject. Okay, C, we have a proportion problem. So guys, proportion problems are always z-test. Okay? Guys, let me see if I can make that a little clearer. Yeah, I think that actually helped a little bit. Okay, so my z-test, again, I'm doing a proportion test, so that's always going to be a z-test. And we say that both of these are greater than 5, so the normal distribution does apply. But guys, you'll notice here we have a different level of significance, 0.10 instead of 0.05. Nevertheless, our z-distribution will look like this. Since my alternative hypothesis is a not equal to, that tells me that I have a two-tailed test. Half of my alpha level, my level of significance, is going to go here. Half of it's going to go there. 0.1 divided by 2. So I have 0.05 in each tail. So guys, the T calculator doesn't do it for me. I got to go to the Z, the normal calculator. And I want area to the left at the bottom to be 0.05. And I compute that and I get negative 1.645. So I know this has to be positive 1.645. So again, I get anything in here, I fail to reject. I get anything from here down or here down, then I fall in the reject region. All right, the last one, I can tell right off the bat that I'm doing a one-tail test. How do I know I'm doing a one-tail test? Well, because the sign in the alternative hypothesis isn't not equal to. So I'm doing a one-tail test, and I know my rejection region. Just think about it. Which way is it pointing? Well, it's pointing to the right, so my rejection region is going to be in the right. And I know that I have to have all of my significance in the one tail. And I also know, because I'm doing a test of hypothesis for a proportion, that I'm doing a z-test, so I'll use a z-distribution. So I've got that up. That's kind of cool. So now I've just got to be careful and make sure that I get the above, because I want to the right. And I want that to be 0.01 and compute. And I see that I get 2.326. All right, guys, I hope that helped. It should have. Now, you might be thinking, well, why didn't he show me within a problem? Well, guys, I'm gonna just be candid and honest with you. If I'm doing a test of hypothesis, I'm not going to do a critical value approach. I'm always going to use the p-value approach. So for the next 9 problems, you're going to see how I would do the problems. And I always tell you I think what is so important about the way that I do the problems is I think this is the easiest way. So guys, when I'm given a problem, it doesn't tell me which way to do the problem. I always use a p-value. And guys, I'm always going to use StatCrunch because it makes the calculations easy. Now, you've seen this problem before, and it says we want to test the claim that the true mean diameter of a manufactured bolt is 300 or 30 millimeters given the population standard deviation is 0.8. Now, I did this problem for you in the PowerPoint, but I want to show you how I would really do the problem. Okay, so first thing I would do is I would set up the null and alternative hypothesis. So I want to test this to see, so test the claim that the true mean is what, 30? And I'm going to test that versus. There's no indication in here that I want to test that it's higher or lower. I just want to test. So when you get that generic language, it's just not equal to. The second thing I'm going to do is I'm going to set my alpha level. This is always going to be 0.05 unless the problem states something different. Well, the problem states 0.05, so it's not an issue. I'm going to set my sample size, and we can see from the problem that that's 100. The next thing I'm going to do is I'm going to calculate my test statistic, and I'm going to calculate my p-value. But guys, I'm going to do this using StatCrunch. All right, so guys, here's the way we do that. We go to Stat, we go to ZStat, we go to one sample, and guys, we have our summary in this problem. The sample mean is 29.84. The standard deviation is 0.8. Our sample size is 100. The test for mu is equal, so we want a 30 there. And in the alternative hypothesis, now notice it uses H sub O and H sub A the way that I'm more comfortable doing. So guys, you just got to have on your radar that depending on some textbooks, some statistical software packages use H sub A, and this textbook uses H sub 1. But guys are saying the same thing, okay? So I've got it set up to correspond with what I have over here. So this part is done. Now a lot of times students will say, well, where do I put in my alpha? Well, you don't. You don't put in your alpha. All you do is hit compute. You can see, just as the video said, our Z-stat, that's our test statistic, is negative 2.00. And our p-value is 0.0455. Guys, that's it. That's all you have to do other than just complete the problem. There's no fancy calculations, nothing like that. Let StatCrunch worry about it. Let StatCrunch do the calculations. Okay? So gang, what we got here is we've got, next thing we're going to compare our alpha. So our p-value, how's it compared to our alpha? Our p-value is 0.0455. Our alpha is 0.05. And our p-value is less than our alpha. This tells us that we are going to reject H sub O because the decision rule is if your p-value is less than alpha, you reject H sub O. If your p-value is greater than or equal to alpha, then you do not reject H sub O. You fail to reject H sub O. So just like we saw in the video, in the PowerPoint, there is evidence to suspect that the manufacturing bolts do not have a mean of 30 millimeter. Now, if it were me, I would want to know more information. I would want to go in and calculate a confidence interval. It's a shame it doesn't just stay in there, but it doesn't. So again, the mean was, what was it, 29.84. Standard deviation 0.08. Sample size 100, so I would want to come in and calculate a 95% confidence interval. And this confidence interval runs from 29.82 to 29.86. So there's more statistical evidence to support that the mean diameter is below 30 because this entire confidence interval is below 30. So saying something's not equal to 30, that just says, well, it's either bigger or smaller. Your confidence interval actually lets you come in and tap in and identify whether it's actually higher or lower without doing a one-tail test. All right, you've seen this problem before. How would I do this? Well, the big thing you have to do is you have to read the problem and determine what distribution. And when I look at this, I see that sigma is not known. So this tells me that I'm going to use a t-test. Again, I'm going to use StatCrunch. Again, I'm going to use the p-value approach. So the first thing I'm going to do is set up the null hypothesis. So average cost of a hotel room to determine if this is true. So mu is going to be 168. And h sub 1, mu not equal to 168. Alpha is probably set for us. It is. And our sample size is going to be 25. Now, it doesn't say anything about whether or not we have a population that's normally distributed. Since we've got a relatively large sample size, I wouldn't be concerned with that. So guys, I'm going to complete it. I'm going to do my test statistic. So it's going to be T stat, and I'm going to calculate my p-value. Now guys, just so there's no misunderstanding, let me go back to the other problem. This test statistic right here would be a z-stat. And it would be a z-stat because, as I talked about earlier, since the population standard deviation is known, we would use a z-test. All right, so let's do it. Stat. Go to t-stat instead of z-stat, go to one sample, and go to with summary. So the sample mean is 172.5. The sample standard deviation is 15.40. The sample size is 25. I'm going to test this, so I'm going to test mu equal 168 against mu not equal to 168. Compute. T-stat is 1.46, and my p-value is 0.157. Now, students sometimes get confused and they'll say, now, Dr. Darborough, earlier you told me I had to multiply my p-value, the area, by 2 when I had a not equal to. Well, guys, if you do this with StatCrunch, it's already multiplied this thing by 2. You only have to do, when you calculate the p-value by hand, you only have to multiply the area to the right or the left of your test statistic by 2 if you calculate that area directly. And I'll give you an illustration of that in just a second. Okay. So guys, here our p-value compares to our alpha. Our p-value is 0.157. Our alpha is 0.05. You should know that 0.157 is bigger than 0.05. So guys, we do not reject H sub O. There's no evidence here that indicates that the average cost of a hotel room in New York is different than 168. Now, if we do a confidence interval, is our interval going to contain 168? Well, it is, because we didn't reject it. So the 168, it's actually going to be contained. So I'm going to go back and do T-stat again, one sample with summary. Again, I wish we didn't have to go through all this, but we do. So 172.5 and 15.8 and 25, right? No, 15.4. And confidence interval 0.95, so we compute. So the lower limit is 166.14. And the upper limit is 178.86. And notice that mu equal 168 is contained in there, which kind of confirms our decision to not reject H sub O. You guys having fun yet? Students typically, I'm not going to say they fall in love with hypothesis testing, but well, that's not what I wanted to do. They do find it kind of doable, I guess. All right, number 4, a phone industry manager thinks that the customer monthly cell bills have increased. So guys, right there, that tells me that I've got that in my alternative hypothesis. So I know I have to have the opposite in my null hypothesis. Since I'm looking at an average, I know this has to be mu, and I know this has to be mu. So have increased and now average over 52. So I know that we have to have 52 here and 52 there. So a company wishes to test the claim. You can assume that sample data comes from a population that is normally distributed. But guys, when you read the problem, you see that the population standard deviation is not known. And guys, sometimes people are like, well, yeah, it is sample standard deviation. Guys, it's a sample standard deviation. That's different than the population standard deviation. So we're going to use a t-test. Second thing, let's set our alpha. Looks like the alpha is not set, so we'll go with the generic industry standard of 0.05, and our sample size is going to be 25 phone calls. So guys, now I'm going to calculate my test statistic and my p-value. All right, so I come over here and I go to stat, I go to t-stat, I go to one sample, I'll go with summary. My sample mean is 53.1. My sample standard deviation is 10, and I have 25 calls. Now, this is one little interesting caveat, I guess, with StatCrunch. It doesn't give you the option of changing the sign of the null hypothesis. Guys, that's okay. Just make sure you've got the right number of 52 there, and make sure that you set the alternative hypothesis correctly. So even though that doesn't say less than or equal to the way that your textbook teaches it, and I will be perfectly honest with you, I don't like that approach. I like putting equal to here. I don't like putting the not equal to that I'm sorry, less than or equal to. But anyway, I mean, it's technically sound. It's logical. It makes sense. But most statistical software packages will create the alternative hypothesis as an equal to. All right, so just double check everything. 53.1, 10, 25, 52, 52 in the alternative and null. And it's critical that this sign in the alternative hypothesis is correct, even though this doesn't show up as we have it. So our test statistic is 0.55. Our p-value is 0.2937. So guys, we know now, we don't even have to write it out, our p-value is greater than our alpha. So this indicates that we failed to reject H sub O. So guys, we cannot conclude that the phone bills have raised and now average over $52 per month. All right, let's go on to number 5. All right, number 5, a manufacturing company claims that it receives 8% response. Guys, when you see percentage as the parameter of interest, that's the key to you that you have a proportion problem. And one of the greatest hurdles in working these problems, at least working them successfully, is choosing the right distribution and choosing the right test. So we have so I know that my H sub O is going to be pi. My H sub 1 is also going to be pi, and I have to read the problem to see what else, okay? So a marketing company claims 8% to test the claim, so there's no test of higher or lower, so I've just got 0.08. So I know also the 0.08 is going to go there, and we have a not equal to. Now, we've got a two-tailed test, but when you let StatCrunch do the calculations for you, you don't really have to worry about that, because it does everything behind the scenes. Second, alpha is 0.05. It's given in the problem, and it looks like the sample size is 500. Now I can go a little bit further, and guys, I like to call this p hat. Your textbook calls it p, but to me p hat goes with the sample. So I have 25 out of the 500, which is what, 0.02? Is that right? It doesn't seem 0.05. Yeah, 0.05. All right, so let's go get our z-stat, and let's go get our p-value. All right, so gang, over here, we're going to choose a different line. We're going to use our prop stat, one sample with summary. Number of successes is 25. Number of observations is 500. And we want, 0.08? And not equal to 0.08. So guys, don't get in too big a hurry that you make just a stupid typo there and end up missing a problem when you actually know what you're doing. So hit compute. Our z-stat is negative 2.473. And our p-value is 0.0134, which is less than alpha, isn't it? So guys, we're going to reject H sub O, indicating that the percentage of responses is not 8%. So I don't know about you, but if it's not 8%, I would want to know what it is. So I would want to look at a confidence interval. Looking at 95% confidence interval, so it looks like it's from what, 3.1% to 6.9%. So the response rate, because that entire interval is below 8%, the response rate appears to be significantly lower than the 8% because, again, this entire interval is below the 8%. All right, 5. Got 2 5s here. What's going on? Well, let's go ahead and do it. I told you I'd do 1 through 5, so we're going to do 2 5s because I did not plan that. All right. You know what? I don't want to do this. I want to do this one because I take this question and do variations of it. And if there's any time between you watching this video and watching the next video, so guys, I'm going to put this over and do it later. All right, guys, I want to show you something. I want to show you a two-tail calculation of a p-value. Show you how, when your test statistic is 1.46, how do they come up with that 1.57? So again, this is a two-tail test. So what I'm going to do here to calculate the p-value, what I do is I set up the sampling distribution, and I have two tails of rejection. Well, the 1.46, which is like right there, to get the p-value, what I do is I take the area above it, but I also have to take the negative 1.46 and take the area below it. Well, because of symmetry, this area is going to be the same as this area, so really all I have to do is find that area and just multiply it by 2. So guys, let me show you how that works out. How when you do have to multiply something by 2, where when you get something by StatCrunch, you don't have to multiply by 2. So guys, what I do here is I'd, as you would expect, go to the T calculator. But now I'm wanting to find area. So I want to find, with degrees of freedom 24, I want to find the area to the right of 1.46. So I get 0.0786. Well, because and that gives me this area here. But I've also got 0.0786 there, so I have to add those two numbers together, making it pretty clear where the 0.157 comes from. So the p-value is nothing more. It starts with the test statistic, and it finds if this had been negative, we would have started with the negative and looked at the area below, multiplied it by 2. If it's positive, we look at the positive part of it, look at the area above, and then multiply it by 2 to get the area that will coincide with the negative part of the test statistic. And again, the reason we do that, we have two tails of rejection, so we have to calculate two areas for the p-value. All right? Guys, I'm done. Take care.